When we think of a habitable or even inhabited planet, our minds immediately jump to a world similar to Earth. A rocky planet located in the so-called habitable zone of its star, with liquid water on its surface and an atmosphere rich in oxygen and nitrogen, like Earth's or like that of early Earth. This type of planet, closely reflecting the conditions of our own, has always represented the ideal model in the search for extraterrestrial life. However, in recent years, astrophysicists and astrobiologists have begun to explore the concept of habitability more deeply and diversely, aiming to broaden the range of worlds that could harbor life, even if they are very different from ours. In this video, we want to talk to you about a new class of potentially habitable worlds that has recently been hypothesized and may already have some promising candidates. Among them, one, in particular, has recently garnered significant attention from the scientific community, and it will be one of the focal points of our discussion. These worlds are known as Hycean planets, a term that may sound strange but encapsulates a fascinating and revolutionary concept. What does this name mean? What exactly are Hycean planets, and why might they be potentially suitable for life? Do they really exist? Let's find out together. First of all, it's useful to review how astrophysicists and astrobiologists define habitability. A planet is considered habitable if it can offer the conditions we deem necessary for the presence of life, at least as we know it. These conditions can be summarized in three fundamental requirements: presence of an energy source, necessary for organisms to perform their vital functions. On Earth, the primary energy source is sunlight, but on other worlds, there could be alternative sources like geothermal energy or chemical reactions. Availability of essential chemical elements, specifically, elements like carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, which form the basis of organic chemistry and terrestrial life. Presence of liquid water, essential for the chemical reactions that form the basis of life. On Earth, all known life forms depend on liquid water, which plays a crucial role as a solvent in biological processes. These conditions, particularly the presence of liquid water on a planet's surface, led to the definition of the habitable zone, a region around a star where temperatures allow for the existence of liquid water on an Earth-like planet. It's important to remember that the habitable zone mainly concerns the distance at which a planet orbits its star, such that conditions are favorable for liquid water to exist on its surface. However, the concept of the habitable zone and habitability itself can be subject to criticism. On one hand, it's a definition that reflects life as we know it on Earth; on the other, it might be too restrictive. There are worlds within the habitable zone that are not habitable at all, like Mars and Venus, which, despite falling within this range in the solar system, do not offer conditions conducive to life. At the same time, there are worlds that might be habitable but lie outside the habitable zone, like the icy moons of the gas giants in our solar system, for instance, Europa and Enceladus. These worlds, though far from the habitable zone, could harbor liquid water oceans beneath an icy crust and thus could potentially support life. An intriguing example of planets that might be habitable, despite being very different from Earth and located outside the habitable zone, are Hycean planets, first hypothesized in a 2021 study. The term Hycean is a combination of the words hydrogen and ocean. These planets are characterized by a dense atmosphere rich in hydrogen and deep oceans covering their surface. But why might these planets maintain habitable conditions, despite having an atmosphere so different from Earth's and being located at considerable distances from their star? The secret lies in the greenhouse effect. The greenhouse effect is a phenomenon that regulates a planet's climate by influencing its surface temperature based on how the atmosphere traps or allows stellar light to pass through. On Earth, free hydrogen is virtually absent, whereas on Hycean planets, it would be abundant. A hydrogen-rich atmosphere could trap heat, maintaining moderate surface temperatures even in conditions very different from those on Earth. This means that Hycean planets could retain liquid oceans on their surface, even if they are far outside the habitable zone. Moreover, Hycean planets would be significantly larger than Earth, with sizes up to twice Earth's diameter and masses up to 10 times greater. This size places them in an intermediate category between terrestrial planets like ours and gas giants like Neptune. They wouldn't quite be gas giants, but neither would they be rocky planets. Their surface would be dominated by deep oceans, hypothetically extending to depths of hundreds of kilometers. These oceans could provide environments favorable to life, similar to Earth's ocean floors, where organisms live under extreme conditions, such as near hydrothermal vents. But do such worlds really exist? Recent observations suggest they might. One of the most promising candidates is the planet K218b, discovered in 2015 using data from the Kepler mission. K218b orbits a red dwarf star in the constellation Leo, about 124 light-years from Earth. This planet has a radius nearly 3 times that of Earth and a mass over 8 times greater. Its characteristics suggest it could be a Hycean planet, with a dense hydrogen atmosphere and potentially oceans on its surface. In 2019, spectroscopic investigations of K218b's atmosphere detected water vapor, a significant discovery that bolstered the hypothesis that this planet could host oceans. However, it's important to note that the presence of oceans remains hypothetical, based on theoretical models compatible with observations, but not confirmed. Furthermore, the atmospheric chemistry of K218b is very different from Earth's, making it more difficult to identify possible biosignatures, signs of biological activity. Traditional biological markers, such as oxygen, carbon dioxide, or methane, might not be reliable on a planet with such a different atmosphere. Therefore, scientists are considering other indicators, such as dimethyl sulfide, a compound primarily produced on Earth by marine organisms. In 2023, a study found potential hints of dimethyl sulfide in K218b's atmosphere, a result that generated great interest, though still far from definitive proof of life. It's crucial to remember that the search for life on exoplanets is still in its early stages, and tools like the James Webb Space Telescope are opening new possibilities for investigating these distant worlds. Planets like K218b represent a fascinating alternative to traditional rocky planets, reminding us that life could exist in forms and places far beyond our imagination. Continuing to explore and study these worlds will expand our understanding of the universe and, perhaps, finally answer the question of whether we are alone in the cosmos.